Hello, welcome to all. Welcome to RK Academy. And today we are going to learn the physics class. As all of you know that today in almost all competitive examinations except in banking examinations, the physics plays a prominent role. Whereas mostly in Navy, SSR AA, the more questions will come from physics. Here, the physics which has a prominence in all competitive examinations where most of the people feel difficult. Today we are going to learn one such topic in which the people have more confusions, that is nothing but optics. Okay, optics is nothing but light. See, whenever you are asked a question that whether you can see the light, most of the people will answer that yes, we can see the light, which is a wrong answer, because the light will be defined by itself as light is an invisible radiation of energy which enables us to see the objects and which carry all the properties of the object. That you may ask me that why we can't see the light. See, you can imagine a room in which you are seated. See, a light, a device which emits the light is there in your room, and if all the walls of your room are washed with white color, just imagine the color of light. Yes, it will be in white color. For example, if you change the color of the walls into blue, the light appears to be in blue color. So, as you are changing the property of the walls, the color of light also changing according to the property. So we can understand that just we can see the reflections of light but not exact light. So we cannot see the light. See, generally light is said to be a form of energy. See, all the physical aspects can't be said to be a form of energy, because if anything is to be said a form of energy, it should have a capability to do some work. As you know that energy is the capacity to do the work. Then light, why it is called as a form of energy? Because light can make us to see the object. Without light we cannot see any object. So here, making us, enabling us to see the object is a work where light can do that. So that is why light is said to be the form of energy. And if light falls an object, it carries all the properties in the sense, for example, if light falls on a person, the light can capture the color of his hair, color of his skin, and its dress and everything, whatever the person has, and it carries all the properties towards our eye and will focus on retina, which causes impulses. Those impulses will be carried to our brain where we can see the image of the person. So truly to say that, if you are saying that you can see a person, truly to say that we can see the image of that person. So the light is to be defined as it is an invisible radiation of energy which enables us to see the object and which carry all the properties of the object. Coming to the light. Here, light, as I told you that in other sense it's also known to be optics. Generally, light, the optics are two types. One is ray optics, the other one is wave optics. One is ray optics, the other one is wave optics. Because ray optics means generally the light as dual nature. Light is said to be in particle nature and also wave nature. The particle nature of the light is given by Sir Isaac Newton. Sir Isaac Newton has given its corpuscular theory. According to him, light is a beam of small, perfectly elastic particles. Light is a beam of small, perfectly elastic particles which are known to be corpuscles. So all these corpuscles, all these particles will emit very closely to each other, which appears to be a ray. So that here, according to Newton, the light is particle in nature. Those particles are very closely to each other as they are emitting in the form of ray. So the ray optics has been proposed by Sir Isaac Newton. From his theory, he explained the most important phenomena like reflection and refraction of light with his corpuscular theory. Okay, but the Newton was unable to explain the other important phenomena of the light, such as interference, diffraction, polarization of light. So the bit may be given that the Newton's corpuscular theory was unable to explain interference, diffraction and polarization of light. And corpuscular theory was proposed by Sir Isaac Newton. Okay? And corpuscular theory was successfully explained reflection and refraction phenomena. So this is Newton's corpuscular theory. From this we are going with the ray. See, generally the light, as we cannot see, so we can understand the light with the help of the geometry. By using rays we will observe and we will understand the phenomenon of the optics. That why it is known to be ray optics. Ray optics means the optics will be understood by the help of the mathematical geometrical rays. That is why it is known to be ray optics. We will come to again ray optics later. The second theory was given by Christian Huygens. See, according to Huygens, he thought that for the propagation of light, there must be subtle, pervaded and complete elastic medium. According to Christian Huygens, for the propagation of light, a medium is required. That medium which is pervaded, subtle and complete elastic medium. That is known to be ether medium. Huygens thought that there is a ether medium. Through ether medium the light propagates. And initially he thought that light propagates in the form of wave. See here, he initially thought that light which propagates in the form of longitudinal wave. See, longitudinal wave in the sense where the particles of the medium, as you know that wave is a disturbance created in a medium. Generally, wave is a disturbance created in a medium. The disturbance is carried from particle to particle and so on. Thereby the wave is propagated. Here, longitudinal waves in the sense, if the wave propagates in this direction, the particles of the medium also vibrates in the same direction. Particles of the medium vibrates in the same direction, and such waves are known to be longitudinal waves. So Huygens initially thought that the light which is propagated in the form of longitudinal mechanical wave, where it was proved wrong later. So the light which usually travels in transverse wave, transverse form. Transverse means if the wave is propagating in this direction, the particles of the medium vibrates perpendicularly to each other. See, here they will vibrate like this in the form of transverse, where crests and troughs are formed. This is crest and this is trough, and crests and troughs are formed. This is the transverse wave. So light are generally transverse in nature. Light generally transverse in nature. From this theory, Huygens proved the important phenomenon that is diffraction and interference, along with reflection and refraction. So generally we can understand the light by the help of waves. So that is why this is known to be wave optics. This is known to be wave optics. Generally, the most convenient method to learn the light, that is ray optics. And coming to understand the light, one must go with the most important phenomena of light, that is reflection, refraction, interference, diffraction, and polarization of light. These 5 are the most important phenomena where light can exhibit. One should understand all these things. Now let's go with these phenomena one by one. Now let's come to know with the reflection phenomena. See, reflection is nothing but bouncing back. That in the sense, when you throw a ball towards the ball, when the ball hits the wall, that will be bounced back. See, means it's coming back phenomenon. The phenomenon of bouncing back is nothing but reflection. So, to undergo the reflection, there should be one surface which is needed, which allow the reflection of the light should be done. That surface, generally surfaces are two types. You can go with a smooth, highly smooth surface. See, this is smooth surface, or you can take a rough surface like wall, like this. See, for example, if the light falls on this smooth surface, see, basically the reflection will take place like this in an order way, which is known to be regular reflection. This is known to be regular reflection. For example, the light falls on a rough surface, then it will undergo the reflection in such a way which is known to be irregular reflection. This is known to be irregular reflection. So generally reflections are two types: regular reflection and irregular reflection. Okay, now let's come to know about the reflection phenomenon. See, generally the reflections takes place on smooth surfaces like glass surfaces, for which one side is painted with some color. So this is a surface. See here, this is a surface where the reflection has been taken place. Hence, this surface is known to be reflecting surface. This is known to be reflecting surface. Okay. So here a light ray is incidented. The light ray is incidented from a source. Hence, it is known to be incident ray. This is known to be incident ray. This light ray falls on a medium at this point P, this point of incidence. So this is known to be point of incidence, POI. And when you draw a perpendicular line from this point of incidence, that is known to be normal. Normal is a perpendicular line drawn from the point of incidence. Okay, and the light will be bounced back, which is said to be reflected. So hence this ray is known to be reflected ray. Reflected ray. Basically, if you see the reflection phenomenon, we are having three kinds of aspects. The very first one is incident ray, second one is normal, third one is reflected ray. So using this, you can understand the incident ray, normal and reflected ray are on same plane. This is known to be the first laws of reflection. First law of reflection. Okay, if you are asked to say about the first law of reflection, in the sense the incident ray, normal, reflected ray are on same plane. And second one is that the angle whatever is subtended with the incident ray and normal, that is known to be angle of incidence. And the angle subtended by the reflected ray with normal, that is known to be angle of reflection. The second law of reflection is said to be that the angle of incidence is equal to angle of reflection. Angle of incidence is equals to angle of reflection. So this is two laws. Laws of reflection, I repeat, the incident ray, normal and reflected ray are on same plane and are on either side of the normal, and angle of incidence is equal to angle of reflection. Coming to here, this is the angle subtended by the reflected ray and incident ray with the surface. These are known to be glancing angles. These are known to be glancing angles. Here G1 and G2 are known to be glancing angles. Okay. So this is the total part of reflection. Then what is the use of reflection? What is the use of the reflection, and what happens when the light undergoes reflection phenomena? Okay. And here, before of knowing that, as I told you that angle I is equals to angle R. See, angle I is equal to angle R. This is most important. Why the light always reflects in such a way that angle of incidence is equal to angle of reflection? Because the light always selects the path for which the displacement is to be minimum or time of journey is to be minimum. It's a human nature. See, for example, if we are going to somewhere, if there are two kinds of paths in which one is short path and another should be long, the human always selects the short path only because the time of journey is minimum. So in such a way, light also selects the path for which the angle of the time of journey is minimum in such a way that angle I is equal to angle R. So this rule is known to be Fermat's rule or Fermat's principle. See, this is known to be Fermat's rule or Fermat's principle. Pierre de Fermat, the scientist who proposed this rule. So, angle I is equal to angle R. The next one is that, for example, if you have seen yourself in the mirror, how it appears in the sense, see, your left side pocket will appear on right side and right side articles will appear on the left side. This is the proper phenomenon where you can understand the left appearing right, right appearing left. This is known to be lateral inversion. This is known to be lateral inversion. That in the sense, for example, if you have taken a light ray, see, this is a mirror. For example, if you keep a letter P here, that appears to be like this. Or in a mirror, if you keep a letter B, that appears to be like this. So this is the phenomenon known to be lateral inversion. Lateral inversion. That is the reason the spelling of ambulance will be written in the manner of laterally inverted manner. So this question may be asked that why the ambulance spelling will be written on ambulance in a laterally inverted manner means as you are seeing the spelling from your mirror, through your mirror, it appears to be perfect, so that you can understand that ambulance is coming from back. This is the most important phenomena, lateral inversion, which is nothing but right appearing left, left appearing right. To understand the phenomenon of light, especially the reflection phenomenon of light, we should have a device. That device is nothing but mirror. See, mirror, before of learning mirror, you should understand that kinds of mirror. Generally, we are having two kinds of mirrors. One is plane mirror. The second one is curved surface mirror. Curved surface mirrors. Generally, plane mirror. This is plane mirror, where one side is painted with red color. The other side will be the glass surface, which is known to be reflecting surface. Reflecting surface. So if you take the plane mirror, if you incident a light ray that meets at a point that is known to be point of incidence, and if you have drawn a perpendicular line, this is normal, and it will be bounced back, this is reflected ray. This is incident ray, reflected ray, and this is normal. And this is the angle subtended by the incident ray with normal, that is angle of incidence, and this is the angle subtended by reflected ray with normal, that is known to be angle of reflection. And these two are the angles which are subtended by incident ray and reflected ray with the surface, which are mentioned as G1 and G2. These are known to be glancing angles. Glancing angles. See, if there is nothing kept, the light would have gone straight. As you have kept a mirror, that is why the reflection has been taken place. If you won't kept anything, the light would have gone straight. But because of placing this mirror, this was reflected up to a certain angle. This is known to be angle of deviation. This is known to be angle of deviation. So this is most important about the angle of deviation. That angle of deviation depends upon the surface and nature of the mirrors. If it is highly smooth surface, that will be more, and if rough surface, that will be less. That depends upon the nature of the surfaces. And this is about angle of deviation. And moreover, here you have to understand one thing very clearly, that from the plane mirrors, images are formed. Generally, images are formed. Generally, images are two types. The very first one is real image and second one is virtual image. Real image and virtual image. Real images are always inverted. Real images are always inverted. Virtual images are always erected. So then what is the difference between real image and virtual image? If an image is able to caught hold on screen, that is real image. That means, for example, I have performed an activity by taking a candle and the image of the candle was formed on a screen or white paper, whatever is kept. That image is real image because you can see that image. You can really see the image. That is known to be real image. Virtual image cannot caught hold on screen. Cannot caught hold on screen. You cannot touch the image. But coming to the real image, you can touch the image. Where you cannot caught hold on screen, that is virtual image. See, the image of ourselves that we are seeing through mirrors are always virtual image. So that is why our images are upright, erected. Erected in the sense the head is on top and feet are on bottom. This is known to be upright, known to be erected. So here also, through plane mirrors, the images whatever are formed, those are virtual. For example, this is a plane mirror. This is a person who kept here at a distance of some x centimeters. And the image will be formed here, that also at a distance of x centimeters. So the object distance is equal to the image distance in the case of reflection through plane mirrors. The object distance is equals to, this is a bit which can come in examination, through plane mirrors the object distance is always equals to the image distance. For example, if you shift this object or if you shift the person to some y centimeters distance, either away from the plane mirror or towards the plane mirror. If you shift a person up to y centimeters distance, either away from the plane mirror or towards the plane mirror, the image also shifts the same distance away from the plane mirror or towards the plane mirror. So the image suffers same distance when the mirror is constant. The condition is that mirror is constant and object is moving up to a certain distance either towards the mirror or away from the mirror. The image also suffers same distance. But now if image is constant, if you are moving the mirror towards the object or away from the object up to some distance, then the image will suffer twice to the distance to it. For example, you move the mirror up to x centimeters towards the object, the image will suffer 2x centimeters from the mirror. So this is the condition you must know. I repeat, if the mirror is constant, if you move the object with some distance, the image also suffers the same distance. But if the object is constant, when you are moving the mirror, the image suffers twice the distance. So this is about the plane mirror. Okay, now let's come to see the curved mirror, curved surface mirror. Okay, let's go with the most of the important things which you can understand from the curved surface mirrors. See, let us take a sphere, hollow sphere. This is hollow sphere in the sense the thing is inside in it, and this is hollow glass sphere. Hollow glass sphere. Now I cut this sphere like this, and I removed this part. I removed this part. Now it's like this. See, if you have seen, this particular surface is appeared to be cave, so that this surface is known to be concave surface. And this is the bulged portion which appeared to be vex. So this surface is known to be convex surface. So generally we are having two kinds of surfaces. This is concave surface, this is convex surface. For example, if I painted the concave surface, that in the sense convex surface is a reflecting surface, this is known to be convex mirror. This is known to be convex mirror, where the concave surface was painted and convex surface is a reflecting surface. For example, if I painted the convex surface and concave surface is a reflecting surface, this is known to be concave mirror. This is known to be concave mirror. Generally, the curved surface mirrors are two types, that is convex mirror and concave mirror. And we should understand the basic terminology of these curved surfaces. See, for example, if I have taken a concave surface, this is a curved surface. The midpoint of this curved surface, is known to be pole. And if you form this into a whole sphere, that will have a geometric center in which the reflecting surface is a part. So this geometric center is known to be center of curvature. This is known to be center of curvature. If a line, imaginary line, whatever is passing through the center of curvature and pole, this is known to be principal axis. This is known to be principal axis. This is a imaginary line passing through center of curvature and pole. That is known to be principal axis. Now, if the light ray is passing through it, that will be bounced back and passes through the principal axis at a point that is known to be focus, principal focus, which is denoted by F, principal focus. The distance between pole to the focus is known to be focal length. And the distance between the pole to the center of curvature is known to be radius of curvature. This is known to be radius of curvature. So these are the important phenomena that we can understand from the lenses. What are they? Very first one is pole, second one is center of curvature, pole denoted by P, center of curvature denoted by C, and principal focus denoted by F. Distance between pole to center of curvature are known to be radius of curvature denoted by R. Distance between pole to focus is known to be focal length denoted by small f. The relation between radius of curvature and focal length is that R equal to 2f. R equal to 2f. For example, in the examination, it may be given that for a concave lens, the focal length is 15 centimeters. What will be its radius of curvature? As I told you that R equal to 2f, 2 into 15, 30 centimeters. Or if it is given that the center of curvature is at 20 centimeters distance from the pole of a mirror, then you ask what is its focal length. So as it is given the distance between center of curvature from pole, that is to be taken as radius of curvature, where you know that R equal to 2f, where f is equal to R by 2, 20 by 2 is equal to 10 centimeters is the focal length. So in this way you can understand R equal to 2f is valid for the reflection phenomenon on curved surfaces. It's very clear. Then by using this you can understand the formation of images. Formation of images. As I told you that images are two types. Yes, then images are two types, real and virtual images. And before I'm going to that, let us go with the concave mirror and convex mirror.